Today I will tell you the next type of chemical reaction, which is the second one, decomposition reaction. Decomposition reaction is just opposite to combination reaction. In the last class we studied that when two or more reactants join together to form a single product, that is called combination reaction. Here decomposition, when a single reactant undergoes breaking to form more simple products. When a single reactant, one reactant only will be there, and that undergoes breaking to produce two or more products, then we call that it is decomposition reaction. Okay, decomposition, splitting, breaking. Okay, when a single reactant, a single chemical substance broken down into two or more products, then such reaction is called decomposition reaction. One very simple example I will tell you. All of you know about iron sulphate. What is the color of iron sulphate? Iron sulphate is FeSO4. Okay, FeSO4, and the iron sulphate is green in color. The iron sulphate crystals are green in color due to the presence of water molecule. Actually, see, this is called hydrated iron sulphate, FeSO4 7H2. That is called hydrated iron sulphate, which is actually the iron sulphate crystals which are green in color. Now, when you heat this iron sulphate, you can see that the water vapor is going out. Okay, some gases are coming out, and the green iron sulphate become white powder. What is happening here? See, the iron sulphate, that is FeSO4, okay, FeSO4 undergoes breaking, decomposition when we are heating it. Okay, when we are heating it, it undergoes decomposition to produce that white powder is iron oxide, and the gases which are coming out, okay, with a specific smell, that is sulfur dioxide and sulfur trioxide. These two are gases which are coming out. I will write here G. The G indicates gas. Okay, Fe2O3, that is iron oxide is a solid. Iron sulphate is also solid material. So see here, iron sulphate is a single reactant which undergoes breaking. Okay, when we are heating it, it undergoes breaking to produce three products. So when a single substance broken down into produce two or more products, then such a reaction is called decomposition reaction. See here, the decomposition takes place by the application of heat. When a decomposition takes place with the application of heat, then we call such reaction, such decomposition as thermal decomposition. So this is an example for thermal decomposition. Okay, what do you mean by thermal decomposition? The decomposition when it is carried out. See, here the decomposition is occur due to the heating effect. So when a decomposition takes place due to the application of heat, then such decomposition reaction is known as thermal decomposition reaction. Hope you understood what is decomposition. What do you mean by decomposition? When a single reactant broken down and produce two or more products, such reaction is called decomposition reaction. Okay. Here example is iron sulphate. Iron sulphate is actually, see, hydrated iron sulphate is FeSO4 7H2. See, that means each molecule of iron sulphate in its crystal state, each molecule of iron sulphate when they are in crystal state consists of a definite molecule of water. That definite molecule of water present in a crystal salt is known as the water of crystallization. That you will study in the next lesson. Okay, what do you mean by water of crystallization? Water of crystallization is the presence of definite number of molecules of water in its salt. Okay, in FeSO4, the hydrated salt of FeSO4 having 7 molecules of water, that actually gives the green color. When it is heated, the water vapor goes out and it becomes white. Okay, such iron sulfate, when it is heated, when the iron sulfate is heated, it broken down into more than 2 products such as iron oxide, sulfur dioxide and sulfur trioxide. Such a reaction in which a chemical substance broken down and produce 2 or more products is known as decomposition reaction. And when the decomposition reaction takes place by the application of heat, then such reaction is called thermal decomposition reaction. For decomposition is the decomposition of calcium carbonate, CaCO3. Calcium carbonate, the chalk piece is also a calcium carbonate. Okay, calcium carbonate is otherwise called limestone. See, when calcium carbonate, CaCO3, okay, calcium carbonate, when it is heated, when calcium carbonate is heated, it produces calcium oxide. Calcium oxide is known as the lime, or simply we can say quicklime, along with the evolution of carbon dioxide gas. Okay, carbon dioxide gas is coming out. So see here, calcium carbonate is a single reactant. When it is heated in presence of, when it is heated, what happens? It produces 2 products. That means calcium carbonate, see, calcium carbonate, C out of CO3, 1 O becomes CaO, and remaining here CO2, carbon dioxide. So one reactant, one chemical substance split or break into 2 chemical substances, 2 products. So this reaction is decomposition reaction. See, this reaction is also an example for thermal decomposition. Why? Because we heated here. This decomposition reaction took place because of the application of heat. Therefore, this is also an example for thermal decomposition reaction. See, this reaction is very, very important because the calcium carbonate, when decomposed and produce calcium oxide, and this calcium oxide are used in the production of cement. Okay, calcium oxide or calcium carbonate are used in the cement industries for the production of cement. So this is another example for decomposition reaction. Another example for decomposition reaction is the heating of lead nitrate. Lead nitrate, the formula is PbNO3 twice. PbNO3 twice is lead nitrate. When lead nitrate is heated in a boiling tube, when you heat it for some time, you can see that the brown fumes are coming out. One brown gas is coming out. That brown gas is nothing but nitrogen dioxide. Okay, nitrogen dioxide. Along with nitrogen dioxide, you can see a powder remaining in the tube, that is lead oxide. And a gas, another gas is coming out, that is oxygen. So see here, PbNO3 twice is lead nitrate. It's a single chemical substance. When it is heated, when lead nitrate is heated, it undergoes decomposition reaction because the single chemical substance undergoes splitting. It broken down into 3 products. A single product become 3 products. So lead oxide, nitrogen dioxide, that brown fumes. The brown fumes which is coming out on heating of lead nitrate is nitrogen dioxide. So lead oxide, nitrogen dioxide and oxygen are released. A single substance, when heated, it produces 3 products. So this reaction is another example for decomposition reaction. And here the decomposition took place by the application of heat. Therefore, it is called thermal decomposition. This is another example for thermal decomposition. Okay, so we studied 3 thermal decomposition reaction, or simply we can say that decomposition reaction. First one, heating of iron sulfate. Okay, heating of iron sulfate, you got iron oxide, sulfur dioxide, sulfur trioxide. 3 products you got. One reactant become 3 products. In the next one, calcium carbonate, when you heated, it gave you 2 products, calcium oxide and carbon dioxide. Here, when lead nitrate is heated, we are getting lead oxide, nitrogen dioxide, the brown fumes, and the oxygen. So in all these cases, a single reactant, a single chemical substance gave you 2 or more products. So when in a chemical reaction in which a single product undergoes breaking, splitting, or lysis to give rise to 2 or more products, such a reaction is known as decomposition reaction. And when the decomposition reaction takes place by the application of heat, that is called thermal decomposition. Then in your lower class, you studied about electrolysis of water. Do you remember? Electrolysis of water. Lysis means again decomposition, splitting. Lysis. Electrolysis means decomposition with the help of electricity. When decomposition takes place by the application of electricity, then such decomposition reaction are called electrolytic decomposition, or we can simply say that electrolysis. Okay, when water undergoes electrolysis, water is H2. Okay, water molecule H2, which undergoes electrolysis to produce hydrogen and oxygen. Okay, so a single molecule, water molecule, when it is undergo electrolysis, application of electric current. In presence of electric current, it undergoes decomposition to produce 2 products. Therefore, it is an example for electrolysis. Okay, see here H2O, CH2. Oxygen only 1, here oxygen is 2. Therefore, I am putting a 2 here in order to balance this reaction. And when I put 2 here, see 2 2s are 4. So, I am putting a 2 here. So, now the equation is balanced. You are getting 2 molecules of hydrogen and 1 molecule of oxygen. Okay, when water molecule undergoes electrolytic decomposition, it produces hydrogen and oxygen in the ratio 2:1. This one you studied in your 8th class. See, take water in a jar and connect 2 electrodes. There will be 2 electrodes. One is cathode, which is connected to the positive terminal of the battery, and another one is anode, which is connected to the negative terminal of the battery. Okay, cathode and anode. Fill water here. Fill water in the jar. Then take 2 test tubes full of water. Take 2 test tubes full of water and just immersed over the anode and cathode. Okay. And now pass the electricity. When you pass the electricity, after some time you can see that the gas bubbles are coming out. The gas bubbles are coming out and it is filling in both the test tube. After some time, you can see that there is more vacant space in one of the test tube. In one of the test tube, more gas is filled. Therefore, here more space will be there in one of the test tube. And in another test tube, if you observe, we can see that exactly half of the space of the first test tube. Now, switch off. Okay, the gas is collected because of electrolysis. The water underwent electrolysis and you are getting hydrogen, the 2 gases you are collecting in the test tube. Now you have to test both the gases. Take the first test tube, any test tube, okay, out of these 2, and say for example if you are taking the first test tube and test it with a burning spincher or a burning matchstick. If it burns with a bluish flame, again it is very bright flame it is producing, that indicates that the gas is oxygen. Whereas if you burn the another test tube it will produce a pop sound. When it produces a pop sound, that indicates that the gas collected is hydrogen. If you observe, you can see that the hydrogen volume will be more than or 2 times than the oxygen volume. That's why I am putting here 2 hydrogen. Now the equation is proved. So from this what we can understand, by applying electricity, by the application of electricity, we can break the water molecules into hydrogen and oxygen. That means this is an example for decomposition reaction. As this decomposition reaction taking place, by the application of electricity, this is known as electrolysis, or we can say that electrolytic decomposition reaction. Okay, so electrolysis is an example for decomposition reaction. Now I will tell you another example for decomposition reaction. And this decomposition takes place with the help of light. When silver chloride, okay, when the white color silver chloride, when we kept in sunlight, the white color silver chloride, when kept in sunlight, it becomes gray. It changes to gray. Why? Because by absorbing solar radiation, by absorbing light, the silver chloride undergoes decomposition. It decomposes to produce silver and chlorine gas. Okay, silver chloride becomes silver, that is solid, and chlorine, which is gaseous. Okay, so silver chloride is also solid. Silver chloride is actually white color solid. When it is kept in light, sunlight, because of the sunlight, it absorbs the sunlight and it divides, it breaks into silver, that is gray color silver and chlorine. So this is an example for decomposition. Why? Because a single substance broken down and produce 2 chemical substances. So this is an example for decomposition. See, this decomposition reaction took place in presence of light. This reaction took place by absorbing light. Therefore, this kind of decomposition reaction, which taking place by absorbing light, is known as photolytic decomposition. This is called photolytic decomposition, or we can say that photolysis. This is called photolysis. Lysis means splitting. Photo means light. So this particular chemical split or broken by absorbing light. Therefore, this decomposition is called photolytic decomposition, or we can say that photolysis. See, another the saying, instead of silver chloride, if we take silver bromide, okay, silver bromide AgBr, it in presence of light undergoes photolysis and produce silver plus bromine, Br2. Okay, Br2. So this is also an example for photolysis. Okay, the decomposition of silver chloride and silver bromide are examples for photolysis or photolytic decomposition reaction, and these reactions are used in black and white photography. This is very important. Okay, what is the use of photolysis reaction of silver chloride and silver bromide may be asked. Okay, this particular reaction is used in black and white photography. This is known as photolytic decomposition reaction. Okay, now we studied about decomposition reaction. In all this reaction, you see, in the first reaction, the iron sulphate is decomposed by absorbing heat. So heat energy is absorbed. Calcium carbonate becomes calcium oxide and carbon dioxide by absorbing heat. Water decomposed into hydrogen and oxygen by absorbing electric energy. Silver bromide becomes silver and bromine by absorbing light energy. So all this reaction, energy is absorbed. So when a chemical reaction takes place by absorbing energy, then such reaction are called endothermic reaction. Okay, the reaction in which the heat energy is absorbed, the energy is absorbed, are called endothermic reaction. So these first one, the decomposition of iron sulphate by absorbing heat, decomposition of calcium carbonate by absorbing heat are example for endothermic reaction. In the previous class we studied that combination reaction are exothermic. There the heat energy is evolved, but here the heat energy is used up. The heat energy is absorbed for breaking the chemical molecule. So when a chemical reaction takes place by absorbing heat energy or absorbing energy, and such reaction are called endothermic reaction. Similarly, when barium hydroxide, take barium hydroxide and ammonium chloride in a test tube. Barium hydroxide and ammonium chloride. I will tell you in the double displacement reaction afterwards. If you take barium hydroxide and ammonium chloride in a test tube, the reaction takes place, and if you touch the test tube in which the barium hydroxide and ammonium chloride are taken, you feel cold. Do you know why? Why? Because in this chemical reaction, the heat energy from the surrounding is absorbed. When the heat energy is absorbed, we feel cold when we touch the test tube. That means the reaction between barium hydroxide and ammonium chloride is also an example for endothermic reaction. Okay.